In question number 16, a block of mass m is placed over a wedge of mass m, which is placed on a horizontal surface. Coefficient of friction between surfaces is shown in diagram. This is mu1 and this is mu2. Value of coefficient of friction between surfaces is given in column 1. Corresponding to entries in column 1 match the entries in column 2. So let's draw the free body diagram of the block and the wedge. So this is the block and this is the wedge. The forces on the block is mg sin 30 degree, that is mg by 2 is acting in this direction, and mg cos 30 degree root 3 mg by 2 is acting in this direction, perpendicular to the surface. So the normal reaction is acting at this point due to the wedge and it acts in this direction, and since due to the gravitational force it tries to move down the incline, the friction force will act in this direction and let it is F1. So the friction force on the wedge will act in this direction, F1. The normal will act in this direction. So the component of the normal in this direction is n sin 30 degree. So n sin 30 degree, and the component in this direction is n cos 30 degree. Its own weight mg is acting in this direction, and the friction F2 is let acting in this direction. Now let's check the entry A of column 1. In column 1, in entry A, it is given that mu1 is 1 by root 3 and mu2 is 0. So this is smooth, so F2 will be 0, and the value of mu1 is 1 by root 3. So if the value of mu1 is 1 by root 3, in that case, if I calculate what is the F1 maximum, then F1 maximum is equal to mu, that is 1 by root 3 into normal reaction, and the normal reaction is equal to root 3 mg by 2, because there is no motion of the block perpendicular to this surface of the incline. So it is equal to root 3 mg by 2. So it comes out to be mg by 2. So the maximum value of the friction in this direction is mg by 2, and it is also mg by 2. So we can say that the block is at rest. And when the block is at rest, let's check what is happening on the wedge. So in that case, the maximum friction is acting. So if I take the component of the friction in this direction, so this angle is 30 degree, so that component is F1 cos 30 degree. So if I calculate the value of F1 max cos 30 degree, so this comes out to be mg by 2 into cos 30 degree is root 3 by 2. So root 3 mg by 4. And if I calculate the value of n sin 30 degree, the value of n is root 3 mg by 2, and sin 30 degree is half. So that value also comes out to be root 3 mg by 4. So the horizontal force on the wedge is also balanced. So the net force on the wedge in horizontal direction is 0, and the net force on the block is also 0. So we can conclude that both the block and the wedge are at rest and they will not move. So the center of mass of the system will also not move. So P and S will be the correct matching. Center of mass does not move and the mechanical energy is conserved. Let's check option B. In option B, the value of mu1 and mu2 both are 0. So if the value of mu1 is 0, then we can say that due to this mg by 2, the block will move down the incline, and F1 is 0 at that instant, and F1 is 0 in that case. So when the block is moving down the incline, then since no external force is acting in the horizontal direction, so there is no movement of the center of mass in the horizontal direction, and there is a movement, and since the block is moving down the incline, the center of mass of this system will move vertically downward. So the correct matching will be R and S, as there is no friction. Let's check option D, in which mu2 is 0 first. Now let's check option D first, because mu2 is 0. So in that case, when mu1 is 1 upon 2 root 3, if I calculate what is the maximum value of the friction F1, so that is equal to 1 upon 2 root 3 into the value of the normal reaction, that is equal to root 3 mg by 2. So it comes out to be mg by 4. So when maximum friction force in this direction is mg by 4, and in this direction the gravitational force is mg by 2, then the net force in this direction is mg by 4. So in that case, there is a relative motion between the block and the wedge. So there is a relative motion between the block and the wedge. In this situation, the friction has reaches to its maximum value. So if I consider this as my system, then the friction will act as an internal force of the system, and the net force in the horizontal direction will remain 0 for this system. So the motion of the center of mass is along vertical line only. So the correct matching will be R, and since the friction is present, the mechanical energy is not conserved. So the correct matching will be T. So the correct matching for the entry D will be R and T. Let's move to entry C. In entry C, the value of mu1 is 1 and mu2 is 1 upon 4 root 3. So in this case, if I draw the free body diagram, then let friction F1 is acting on the block in this direction. So if I calculate the maximum value of this friction, then it comes out to be mu into n. So mu is 1 into n is root 3 mg by 2. So this value is greater than mg by 2. So in that case, we can say that the value of F1 is not reached to its maximum value, and it is equal to mg by 2 because static friction is self-adjusting in nature. So mg by 2 gravitational force acting in this direction, friction mg by 2 will act in this direction. So the block will at rest. So this case is similar to the case A. So the correct matching will be P and S. So the correct matching for the entry A is PS, for the entry B it is RS, for entry C it is again PS, and for entry D it is RT. Let's move to question number 17. In question number 17, a cubical container of side length A is fully filled with ideal liquid of density ρ. Vessel is given acceleration A, whose values are mentioned in column 1, and comparison of pressure is mentioned in column 2. Match the entries in column 1 with the entries in column 2. So in entry A of column 1, A is equal to 3I cap. So when the cube is moving in this direction, then the pressure on this face and the pressure on this face are equal. So we can say that the correct matching will be Q and R, because the pressure at point A and D are same, which is not equal to C, and the pressure at B and C are same, which is not equal to A. So let's check entry B. Acceleration is given as 1 by root 3 into 3I cap plus 3K cap. So the direction of acceleration is in this direction. In that case, we can say that this point D and B is symmetric to the direction of motion. So the pressure at point D and B must be equal. So the correct matching will be S. Let's check the entry C of column 1. When A is equal to 3K cap, the container is moving in this direction. So the pressure at different points on the front face, this face, is same. So we can say that the pressure at point C and D are same. Similarly, the pressure at point A and B are same but is different from C and D. So the correct matching will be P. And when A is equal to minus 3J cap, when the container is moving in this direction, then the pressure at different points on this face are same. So the pressure of point A, B, C and D are same. So the correct matching will be T. So in question number 17, the correct matching for entry A is QR, for entry B it is S, for entry C it is P, and for entry D it is T. Let's move to question number 18.